Okay, so hey everybody, this is Mr. Bells, and I wanted to talk to you about a few different things that will help you with your homework today. We're going to review some stuff, so let's take the point 6 comma 10 and the point, let's go -2 comma 4, and we want to do two things. Let's call this point A and this point B. So just like practicing from our last 2 days, we want to find out what AB equals, and then we want to find the midpoint of segment AB. So just like that. So what I'm going to do is I'm going to give you a quick little sketch over here. And this way, again, you can kind of do this at your own pace if you need to. 6, 10, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 10's right up there. 6 comma 10. And -2, 4. 1, 2. 1, 2, 3, 4. -2, 4 is right there. And so we want to find, first off, the distance from A to B. Well, one of the things we said that we could do is that we could make this into a right triangle, and we could use the Pythagorean theorem. So I need to know what each of these lengths are. So this length right here is a vertical length, and the two vertical numbers are this 10 and this 4. So how far is it to get from 4 all the way up to 10? Well, that's 6. And then how far is it to get from -2, the x version here, to the x over here, from -2 all the way to 6? And that's 8. So if I do the Pythagorean theorem, 6 squared plus 8 squared equals hypotenuse squared. That's 36 plus 64 equals hypotenuse squared. 36 plus 64 is 100 equals hypotenuse squared. And then we got to square root both sides, and the hypotenuse actually equals 10 in this case. So my distance is 10. That's how far it is from point A to point B. The second thing that we want to look at is what's the midpoint of AB. Well, the midpoint formula we said we could get by adding the two x's together, x1 plus x2 over 2, like that, comma y1 plus y2 over 2, like that. So I'm going to go ahead and add my x's. So my x's are 6 and -2. 6 plus -2 is 4 over 2, comma. And then my y's together, that's the 10 and the 4. 10 plus 4 is 14 over 2. 4 over 2 is 2. 14 over 2 is 7. So 2 comma 7 is supposed to be my midpoint. So if I go ahead and look at my actual triangle and I go 1, 2, 1, 2, 3, 4, 5, 6, 7, like, oh my gosh, that makes sense. That's in the middle of that length right there. Okay? So that's distance formula and midpoint, and that's all review stuff that we've had. So some of the questions I'm going to ask you is to do distance formula and midpoint. Now this is going to be new stuff. And some of this new stuff is going to be about angles. And if it's in our textbook, this is actually section 1-5. Section 1-5. And we're going to take a look at the names of a bunch of angles. We're going to skip perimeter and area. I just don't think it's a good thing for you to be able to do. So what the heck is an angle in geometry? Well, if we have a ray, we have another ray, and those two rays share the same endpoint like this, then we're going to say that we can name this angle a couple different ways. And in order for it to be an angle, we're actually talking about how much open space there is between these things. So with my hands like this, the more I open them like that, the bigger the angle gets. And I think you've seen enough stuff with angles before that this isn't brand new. Okay, so how do I call this? What's a way to name this? If there's only one angle that comes off of a vertex, and this point B is called a vertex, I could call this angle B, just like that. However, if there's more than one point, one other ray coming off this besides those two, then I need to use 3 letters. And I always put the vertex in the middle, so I could call it angle A, B, C. That's the opening from A to B to C, that's this opening. Or I could call it angle CBA. That's from C to B to A like this. But B always has to be the vertex or the only one that's there. Now granted, if I had this, another angle coming off of here, and I call this point D, then I can't call this angle B anymore, because I don't know if it's this angle where the red is, or if it's this angle where that red is, or if I'm talking about the whole thing, that green one. So you can see why I can't just use one letter anymore. So let's say I wanted to use where this red arrow is. Then I could call that angle CBD or angle DBC. So that's how we have to refer to those angles. Now, the next thing we're going to talk about is the size of those angles, the size of those angles. And we have names for them. So if I had a ray that was going out just like this, and I had another ray that was right on top of it pointing in the exact same direction, that would be a 0 degree angle because it has no opening, 0 degrees. If I had an angle or a ray going here and another ray that was going up like this, that's less than a right angle, so between this opening X that we have right here, this opening in X degrees, so 0 is less than X is less than 90 degrees. That one's called acute. And again, I think you've heard these terms before. If it's exactly a right angle, then it's 90 degrees. And we use this little symbol right in here, a little box in the corner. That's 90 degrees, and that's called a right angle. And then if it goes open bigger than 90 degrees, right? So we started here, and we got it a little bit kind of acute. We get it to a right angle, that's 90 degrees. I go further than a right angle, and that looks like this. It's open more. So that opening right here, we'll call that X degrees also. We'll just represent as X again. So 90 is less than X is less than 180 degrees, because 180 degrees is all the way open. That's called obtuse. And then the last thing, we talked about this earlier. What happens if you had two rays that go in opposite directions? So it's opened up all the way to here. That is exactly 180 degrees, and that's called a straight angle. S-T-R-A-G-H-T. Okay? So 0 degrees or a 0 angle, you can call that acute, right, obtuse, and straight. Good deal? So what we're going to do now is we're going to look at a protractor, and this is in your book. You can use this to reference it if you want. So what we're going to do is we're going to talk about the measurements on this thing. And this shape right here, this thing here, is called a protractor. And a protractor, P-R-O-T-R-A-C-T-O-R, helps us measure angles. Awesome. So we're going to go with measure of angle AOB first. So here's point A, B, C, D, E, and there's point O. So AOB represents this angle opening right here. So I'm going to start with the smaller numbers, 0, and go up. So it's 10 degrees to there, 20 degrees to there, 30 degrees to there, 35 degrees. So AOB is 35 degrees. And again, this is page 22 in your workbook. So you can open it up to there and have those in there. Next one's going to be AOC. So AOC is actually this opening right here. And I'm going to go again with those numbers, 0, 10, 20, 30, 40, 50, 60. And then halfway between 60 and 70, or you could count the little things, smaller to see. 1, 2, 3, 4, 5. That would be 65 degrees. Now, I don't want to call this 115 because you can obviously see that it is smaller than 90 degrees. Okay? So I always need to start with 0 when I'm starting from the horizontal and moving up. The other way you could look at it is you could go, well, it's 180 minus 115, and 180 minus 115 is 65. Okay, so now I'm going to do BOC. Well, BOC is this section right in here. So that's going from 35 degrees all the way up to 115 degrees. And I can get that by doing subtraction. Sorry, not from 115. Ooh, that was bad. 65 degrees. I was looking at the outside set of numbers. Don't keep them consistent. So 35 degrees all the way up there to 65 degrees. And 65 minus 35 is 30 degrees. Okay? Now I'm going to skip a couple right now. I'm going to go all the way down here to AOE. This one's all the way down there at the bottom. AOE. AOE is from here all the way over to here. Now I could take those inside set of numbers, 0, 10, 20, 30, 40, 60, 90, 100, 110, 120, 130, 140, 145, and do it that way. Or I could do it this way. Watch. I can go this amount, and I could say that's 10, 20, 35 degrees, and then I know that I don't want that because it's the whole thing. So I could do 180 minus 35 degrees, and I also get 145. And it's pretty obvious that is big, right? That is an obtuse angle. Okay? So when we go through these things, we want to be able to know by the names of them what they are. Acute, right, obtuse, straight, zero, yes. And we also want to be able to find out measurements for them. So what I'm going to do now is I'm going to go back to this sheet, and I'm going to give you a couple things that I want you to be able to follow through on. So first off, let's say that I had this angle right here, and I told you that the measure of the angle was 2x plus 3 degrees. Good deal? And this was angle BEF. Angle BEF. And over here, I got another angle. And this is angle CAJ. And I told you that the measure of angle BEF was congruent to the measure of angle CAJ. That means that both these two things are the exact same size. Okay? Now let's say that this was 56 degrees. That angle opening was 56 degrees. And I just made that up and I wrote it down there, 56 degrees. So I want to know, what does x equal? Well, you can use algebra now. If these two things are congruent, then those two things are the exact same size, which means we can write the equation 2x plus 3 equals 56. And then we can solve that through algebra. Minus 3 minus 3. 2x equals 53. Divide by 2, divide by 2. X equals 26.5. Good deal? Now again, that doesn't mean the angle is 26.5 degrees. That means the value of x is 26.5 degrees. But that's just using some of our properties of algebra and geometry together. Okay? So, I'm going to do this for you. I got to show you. I just got a text from one of my daughters. This will be entertaining for you, maybe. But one of my daughters, currently right now, is in the ER up in Grand Rapids because she was sewing something with her sewing machine, and yes, that is a sewing needle that she put right through her finger. Didn't expect to see that in this video, did you? And she just texted me saying that she's in the ER, she's doing okay, and she's going to be seen soon. Okay. Okay, so next, I'm going to do another one for you. I'm going to give you this angle right here. Good deal. And I'm going to say that this angle is 3x plus 102, 3x plus 102, and we're going to call this angle DAB, and I want to know how big is angle DAB if x equals 12. Okay? So what's the measure of angle DAB if x equals 12? Awesome. So this is different, right? I'm not telling you what the whole thing is. I'm telling you what x is. So you can take the value of x, 12, and you can stick it into there. 3 times 12 is 36. 36 and 102 is 138. So we would say that it's 138 degrees. And that would be another example that we could do for this one. Now, the other day, right at the end of class, yesterday right at the end of class, we worked on something like this, where I had a point here and a point here and a point here, and this was 4x plus 2, and this was 3x plus 10, and I said, this is point A, this is point B, and this is point C. I said that B is the midpoint of segment AC. Well, if B is the midpoint of segment AC, then that means that these two segments are congruent, and I can therefore write 4x plus 2 equals 3x plus 10. I can then subtract 3x, and I get x plus 2 equals 10. I can subtract 2 and subtract 2, and I get x equals 8. And if x is 8, I can plug that 8 up into here. I get 4 times 8 is 32, plus 2 is 34 for that length. So AB equals 34. I can plug 8 back into here. 3 times 8 is 24, plus 10 is 34. So BC equals 34. And look at that, they are the same. And then if I wanted to know my last thing, AC, the whole big thing, we would know that that is 68. So I'm going to turn that off because I do have 4 daughters, and the rest of them are all commenting now about her sister and shoving a needle through her finger. Okay, so the last thing that I'm going to talk about is this, is what happens when we have something that looks like this. This is an angle bisector. This ray bisects this bigger angle if this angle right here and this angle right here are the same size. And if we put little tick marks like we did on the lines to make the segments congruent, these little tick marks right here are symbols that make the angles congruent. So I'm going to go ahead and put some letters on here. I'm going to go A, B, C, and D. And I would know based on those little tick marks, those little arc marks in there, that the measure of angle ABC is congruent to the measure of angle CBD. That those two things are equal. Now, if this was 4x plus 2, let's make it 4x plus 20. 4x plus 20. And this was 6x, let's go, 6x plus 12, 6x plus 12, then if those two angles are congruent, that means they're also equal. I would be able to write this as an equation. 6x plus 12 equals 4x plus 20. Then I could solve it, and I'd subtract the 4x over here, and I get 2x. I'd subtract the 12 over there, and I'd get 8, and I'd know that my x equals 4. Yay? And if my x equals 4, I can take that 4 and I can plug it into there. 4 times 4 is 16. 16 plus 20, that's a 36-degree angle. I take 4 and I plug it into there. 4 times 6 is 24. 24 plus 12 is 36. And now I'd know that angle ABC is 36 degrees, angle CBD is 36 degrees, and angle ABD, the measure of angle A to B to D, is both of those put together, 72 degrees. Awesome. So again, I hope this helped. The problems that I'm leaving you are with the sub. You gotta watch this video first. Again, thank you for doing it. We will talk to you later. Make sure you get that done. Our test is coming up soon.